Hey everyone, my name is Anvita Bansal and we are back with another lecture based on linked list. So the problem for today is merge two sorted linked list. I'll just check if I'm live. Yes. So let me show you the problem. This is your question. Before I start off with this question, I just want to say if you guys have gone through yesterday's lecture, then this question is very easy. You already have the solution for this. I'd say the problem that we discussed yesterday was a modified version or a better version of this question, in which we were already using this kind of a logic that we might need to use for solving this. Now you already have the hint if you have seen yesterday's lecture. If not, let's discuss. So you are given two sorted linked list like this. This is one linked list, this is another linked list. They are of different sizes. Your task is to merge both the lists in place and return head of the merged list. Very simple. Let's understand. Let me take this example. I'll take anything. Fine. So let's say you have list 1, linked list 2. Okay. List 1 is, let's say, 1, 2, 3, 4, 5. And then I have 10. But let's do one thing. Let's make it a better list. 5, 10. What do we have? 15, 40. Okay, fine. What I need to do is I need to merge these two linked lists in sorted order. One prerequisite that question has given to you, that both the lists are already in sorted order. You can see 5, 10, 15, 40. This will be in sorted order. Now you have to merge them, which we have already done for arrays. If you guys recall, we have done the similar thing for arrays. Okay, I'll directly come to the solution. We used 2 pointers in that approach. When we were trying to merge two different arrays, two sorted arrays, we wanted to merge two sorted arrays to form another single array which is sorted, right? So we use 2 pointers. Exactly this is what we are going to do in this problem also. The brute force approach that might come to your mind would be that take an extra, maybe you can take one extra node, okay, let's call it a dummy node, and then rather than taking a dummy node, you can take an extra space of probably an array. You already know this is of size n, this is of size m, or you can take any kind of data structure in which you want to store them. So you store them in one data structure, for example an array. Okay, you have them, you already iterate through linked list 1, store it in this array. So you will have 5, 10, 15, 40. Then you iterate through another linked list and store the data or nodes whatsoever, 2, 3, 20 in this. Now you sort this array. Sort arrays dot sort. You apply this sort on this particular array. Now you have the data in the sorted order. So you will have something 2, 3, 5, 10, 15, 40, and now that is how you can convert it to a linked list again. So that is some task that you might have to do, but this is not an optimal approach. Why? Because one, you have to take an extra array, then you will be iterating through that array again to convert it back to a linked list, or maybe you can just keep a track of which is the head node. For that you will have to traverse through it to find the node. So these are some things, but we can easily do it using a 2 pointer approach. So what are we going to do here? Since it's a linked list, it wouldn't be exactly what we did in arrays. Here let's do one thing. Let's take a dummy node. Okay, so that dummy node, initially I'm giving data -1 in my dummy node. Okay, let's take one more node. Let me write it here. There will be a dummy node. There will be, let's take another node which is your temp node. Got it? What is the use of these nodes? You'll understand. And initially, let's say this is in your linked list, head 1 will be given, head 2 will be given. I'll take h1 which is pointing to head 1 and h2 which is pointing to head 2. Now what? Now nothing, you will just make the comparisons and start forming the links. So right now my temp is pointing to the dummy node. Okay, what you have to do, check which one of them is the smaller value? Obviously the one pointing the head to, which is pointing to 2, right? So your task should be that your temp should be now pointing to head 2. Basically this is where your temp is now. Okay, also you are ensuring that dummy initially your temp node was present exactly where your dummy node was, which was the extra node we created. Now my intent behind is that this temp node is now pointing to head 2, right, which is 2. I'm writing it like this here. I'm writing the data itself, so don't get confused. Now the next step should be that I move my temp to temp.next, which is actually at 2, right? Since you made this comparison, your temp actually is pointing to head 2, which I am representing to you here. Now your h2 will move to the next pointer, that is h2. Temp is still at 2, right? Now you will be comparing between h1 and h2 again. Which one is smaller? This should be 2, 3. Okay, this is 3. Now 3 is smaller, so temp should be pointing to h2. Why? Because it is smaller than h1. So basically now your temp is pointing to h2, and then simultaneously you have to do one thing, that it's temp.next. You want this link to be pointing to h2, right? So you will do temp.next is pointing to h2, the one which is smaller, right? And then you will move your temp pointer to the next pointer. So this is pointing to this, and temp has been moved here, and since h2 was smaller, h2 has come at this position. Now compare them, which one is smaller? Obviously h1 is smaller. So now your temp pointer should be pointing to h1. For that, what you have to do, first you have to form the link. Temp.next should be pointing to h1, which is 5. Then you move your temp pointer to the temp.next, and simultaneously your h1 will go to the h1.next, so that the next comparison can be made. 10 and 20, which one is smaller? Clearly 10. So temps.next should be pointing to h1, which is 10. Then your temp moves to temp.next, which is this. Simultaneously h1 moves to h1.next. Which is smaller, 15 or 20? Clearly 15. So temp.next is now pointing to h1, which is 15, and h1 goes to the next pointer, temp goes to its next pointer. Got it? Now which one is smaller, h2 or h1? Clearly h2. So temp.next is pointing to h2 now. Temp goes to the temp.next, h2 goes to h2.next, which is null, right? Now h2 is pointing to null. So this is when you know that whichever loop you are using to form these links, the stopping condition or the terminating condition for that loop should be while one of, see, you do not know which of the for two linked lists is smaller in length. So we'll just put a condition here, while h1 is not equal to null. If one of them becomes null, that means you come out of the loop. You have already organized the links which were supposed to be, which were needed to be in sorted order. Now the leftover links will already be in sorted order if one of the two linked list head comes to null, right? While h1 is not equal to null and h2 is also not equal to null. So basically when one of the nodes starts pointing to null, that means you have already traversed through one of the linked list. Now what? Within this, I'm just writing the pseudocode so that you can understand. Within this loop, what you are doing? You are making a comparison. If your h1.data is less than h2, h1.data is less than h2.data, right? What are you doing? You are doing nothing but you are making your temp dot next point to the smaller node equal to h1, right? Then you move your h1 to h1 dot next, so that next comparison can be made with the next data, next node. Okay, if this is the case, you do this. In else condition, that means your h2 was smaller, you are doing the similar thing, but in this case your temp dot next will be pointing to h2 now, and h2 is moving to h2 dot next. Now you must be wondering, we are not moving temp to the next pointer. Till now what we have done, we are just moving a temp pointer point to the smaller data, but eventually temp should also move to its next pointer, right? So since we have to do it for both the cases, I'll just write it after these if else conditions, that when you hit any of these conditions, after that temp equal to temp dot next. This is one thing that we are doing. Okay, then what you come out of this loop, when you come out of this loop, what could be the possible conditions? Either h1 is null, or h2 is null, or both null. Both are null if your linked list, both the linked lists are same, equal in size, right? So if any of the conditions is true, that means if h1 is null, that means what you should be doing now, this means that your h1 has been exhausted. Now there is a possibility that h2 still is pointing to some node in your second linked list, right? So all the nodes that are present in h2, the remaining nodes should be attached after this, correct? So you do the same thing. Temp dot next should now be pointing to the node which I'm assuming to be not null, right? h2, correct? And what else? If in the other case h2 is null, then temp dot next should be pointing to h1, so that all the subsequent links after that h1 will also be linked to temp, right? And that's all. And finally, what you want to return, you remember that we took a dummy node initially, and temp node was pointing to dummy node. Then we simultaneously started moving temp to temp dot next and so on and so forth. So dummy dot next must be pointing to our head node of this linked list finally, which is in sorted order. So I should be returning dummy dot next. That's all. We have written the entire code actually. There's nothing left now. So what would be the time complexity? Since we are traversing through each node of both the linked list for exactly one time, the time complexity will be equal to big O of m plus n, where let's say this is the size of L1 is m, the size of L2 is n. So big O of m plus n will be your time complexity. We did not take any extra space. Big O of 1 is your space complexity. Got it? So it was a simple one, very simple one. If you have gone through yesterday's lecture, now I'll just move to the code part. Give me a moment. Let me just check if you guys have any doubts. Meanwhile, you can write it in the chat. Fine, then I'll just move to the code. Okay. So we are taking extra nodes, node dummy, let's take equal new node. Initially we're giving value as -1, which doesn't matter at all, whichever value you give data. Then node temp equal to, you are pointing it to dummy initially. Then node h1 is pointing to head 1, okay, head 1. Node h2 is pointing to head 2, fine, which will be this node. Now your while condition comes, while h1 is not equal to null and h2 is not equal to null. What are you going to do? You are checking if h1 dot data is less than h2 dot data. What are the things we are doing? We are making a temp dot next point to the smaller one, which is h1, and then you are moving h1 to h1 dot next for the next comparison. Same thing you do for the else case, just that here temp dot next would be pointing to h2 and h2 will be pointing to h2 dot next for the next comparison. Okay, when you come out of these if else conditions, staying within the loop, you must be making your temp point to the temp dot next, because you have already added one node after temp. So temp should be at its right position. Now what else? Now while loop is done. Come out of this while loop. What could be the case? If let's say if h1 is null, I'm assuming maybe h2 is still not null. So in that case, temp dot next, that means temp should be forming a link with h2. And if h2 is null, temp dot next equal h1, because we are assuming that h1 might not be null at this point in time. If both the things are null, right? If h1 is null, you are anyway pointing to null pointer, so that wouldn't affect. And finally you return dummy dot next. This is the reason we took dummy node, so that we can have the address of the next pointer, which is actually the head of the newly formed list, which is in sorted order. Let's submit it. Fine. So that will be all for today. I hope you understood the problem. Try to do it on your own, you'll be able to. Fine then. That was all for today. Let's wrap it up. I don't see any doubts. Fine then, see you all in the next lecture. Bye bye, take care. One doubt, can we initialize dummy node equal to null? See, if you initialize dummy node with null, right, then how will you get the address of the next pointer? The purpose behind taking dummy node is that there is some legit node like dummy, which is actually pointing to the temp, means temp will later on go to temp.next, and actually it will be the head of the newly formed linked list, which will be 2 here. So dummy's next should be some node. If you will make dummy itself a null node, how can you connect a node after a null node? Have you ever seen null node pointing to a node having some value? Have you ever seen a linked list like this? No, right? This is the reason we are not initializing dummy node with null. We have to give it some value. Got it? So this is the reason we are not making it null, because null pointer will not be pointing to a next node. Okay? Is your doubt clear, Ayush? Right. Null pointer exception. Correct. So, did you understand this? Good. Okay. Let me know if you guys have any more doubts. If not, then wrapping it up, guys. Thank you and see you all in the